Hi guys, today I'm going to show you how to rationalize radicals. Now, the reason I'm making this into a video is because this tends to be a little confusing for a lot of people. So I figured it'd be easier if I actually made a video and you guys can pause the video or go back to the video or whatever you'd like to do to maybe help you learn this a little better. Okay, so I'm not going as fast. So rationalizing radicals, okay? Guys, we have simplified radicals, we have added radicals and subtracted, we have multiplied. Rationalizing radicals is basically dividing them, okay? So we're going to start off really simple, okay? But actually, even before we start dividing, remember what we did in multiplying radicals. Remember what happens when you have a radical and you multiply it by itself. Okay, radical 3 times radical 3 is radical 9, which is indeed 3. If you have the square root of 7 times the square root of 7, you get the square root of 49 to be 7. Okay, if you have the square root of 5 squared, it's going to be the square root of 25, which is just 5. So I think with this, you can see the pattern that's emerging. Okay, whenever you multiply a radical by itself, you could actually eliminate the middle and just get the number under the radical sign. That's with anything. So if I had the square root of, I don't know, a smiley face with an X, with a Y, with a Z, and I decided to square it, I'm just going to get what's under the radical, which is smiley face, X, Y, Z. This concept is very important with rationalizing or dividing by radicals when you have one radical in the denominator. So for example, if I have 13 divided by the square root of 6, okay, what you need to know is you can never, ever, ever have a denominator be a radical. You can never have, maybe I should have wrote a radical in the denominator, okay? But you can never, ever, ever have that. That's an irrational number, okay? And remember when we discussed irrational numbers in the beginning? Irrational numbers are crazy, okay? They're numbers that do not make sense. Well, I'm not going to have a crazy person in my denominator that's holding me up. Who knows if they're not just going to walk away? So we can never, ever have that. So based on what we did here, we know, excuse me, if I multiply this denominator by a radical 6, it's going to be a radical 36, which will just give me 6. So I could do that, except I sometimes think who I am. But I just don't have the power to stop multiplying things. Okay, it's just not allowed. You're changing something's value. However, if I multiplied this fraction by, let's say, a radical 6 over radical 6, what is the value? The value. Okay, what does radical 6 divided by radical 6 really equal? Well, that really equals 1. And we know that when we multiply anything by 1, we're not changing the value. 5 times 1 is still 5. 6 times 1 is still 6. So that's why we're allowed to do this. And it has to be the same numerator divided by the same denominator because it'll equal 1. And that's why we're allowed to do this. Now, when I multiply, again, multiplying radicals is easy. Just multiply across. This becomes 13 radical 6 over 6. And that's it. Okay? We can't reduce the 6. And if we can reduce these two numbers, we should. In this case, we can't. 13 and 6 cannot be divided by the same number. So basically, that's all we're doing. We just need that to to clear out the radical in the denominator, we need to multiply it by the same number. So let's look at another one. Let's say, let me silence my phone that is going off as I'm trying to make this video, because that's just normal for me, right? Okay, hold on. Can't speak right now. There. Okay, so I have, let's say, 11 over radical 11. Again, you can never, ever, ever have a radical in the denominator. So what I'm going to do is I'm going to multiply this by radical 11 over radical 11. This equals 1, so I'm not changing its value. I'm not making it bigger. I'm not making it smaller. I'm just rewriting it. 11 times radical 11, it's a lot of 11s here, is that. And now watch what happens here. Radical 11 times radical 11 is just 11. Now this is what I was talking about in the previous example. I can reduce these two. I can't reduce this. Okay, you can never reduce a non-radical with a radical. But these can cancel out, and I'm just with square root of 11. Okay, I'm going to show you a few more examples. All right, let's say I have something like this. 5 over 3 radical 2. Again, you cannot have a radical in the denominator. So what we're going to do is we are going to multiply the numerator and the denominator by radical 2. When I do that, now you have to be a little more careful with this. The numerator is easy. It's just 5 radical 2. Okay? Here, it's 3 times. We multiply these two together because these are the radicals. Well, we know it's going to be radical 4, which simplifies to 2. So technically, this is 3 times 2. This is the 3. And radical 2 times radical 2 is 2, which gives me now 5 radical 2 over 6. This is going to be the final answer. Okay? Now, you might say, wait a minute, can I reduce 2 and 6? Oh, no, 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 because this is a radical and this is not. Okay? Let's try another one. Let's do something like this. If it's given to you like this, 5 over 4, okay? I always say this is the lazy way of writing the radicals because basically it's a radical in the numerator, radical in the denominator, but you didn't want to put the radicals, okay? So what you are going to have to do, this is someone who just didn't want to write it twice. This one actually simplifies nicely because all you first do is rewrite with 2 radicals. So let's write that. Rewrite, everybody gets their own radical with 2 radicals. And now we simplify it. Now this one worked out nice because we had a perfect square in the denominator. So this just becomes the square root of 5 over 2. And we have nothing to do. You can have radicals in the numerator, that's fine, but you cannot have radicals in the denominator. Let's try another one like that, where the radical in the denominator does not, it's not perfect, because so few of us are. Again, big radical, 1 over 3. First, we're not going to share our radicals. We're going to give everybody their own radical. Now this one works out where there's a perfect square in the numerator. Okay, so if you identify that there's a perfect square there, you might want to take this extra step. But it doesn't matter that it was a perfect square in the numerator. We do not have a perfect square in the denominator, so we are still going to have to rationalize that denominator. Okay, 1 times radical 3 is radical 3. And again, this multiplies out and you just get 3. And there is your final answer. Okay? And guys, it's okay that we can do, let's say radicals in the numerator, radicals in the denominator. So square root of 7 over square root of 5. Again, we just have to worry about what's in the denominator. I don't care that there's a radical 7 in the numerator. I just always worry about what's in my denominator. That's what's holding up my fraction. Again, we multiply it by the same numerator over the same denominator. We get 35 over 5. And that's it. Sometimes you can simplify them, and I just want to show you one more where we can simplify it. Oh, I don't know why there's an M on that paper. Let's just reuse it, okay? So let's say we have the square root of 6 over the square root of 3. Again, my first step is to rationalize the denominator. I will multiply the numerator and the denominator by radical 3 over radical 3 because that equals 1. This is going to now give me the square root of 18 over 3. I no longer have a radical in the denominator, okay? But guys, bells should be going off in your head right now. Ding, 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 ding. Okay, you should be saying, wait a minute. I'm not going to leave a radical 18. I could break that down into the square root of 9 times the square root of 2 over 3. That breaks down to 3 radical 2 over 3. And look what happens very nicely. 2 non-radicals, both divisible by 3. And my final answer, I'm running out of the P, so I'm going to write it here, is radical 2. Okay, so this is just a mini lesson, okay, on rationalizing radicals. These are the easier ones. I'm not going to bring you into the, well, we're just going to stay with this right now. Okay, so what I'm going to ask you to do in your files, there's a classwork paper. Okay, it's called Introduction to Pre-Calc, Rationalizing Denominators and Rational Exponents. I basically, guys, just did this whole column. Okay, so what you're going to do for the remainder of the class period, okay, since I'm just giving you the video and I'm setting you free, is you are going to do the rest here. Okay, so from 2 to 24, and we did the first column. So you're doing these columns. So this is classwork / homework since your video is only like 13 minutes long. So after you're done with the video, okay, this is in your files, or if you want, you could just freeze the video here, and there you go. Now you know you're doing these problems here. Let me make it boxed in. Okay, so everything in there is your homework, and I will see you guys on Friday. Whoops, sorry, I got fuzzy there.